These are the answers for exercise 12.6, and it's on proving similarity and determining sides. So for question 1, it says prove that triangle ABC is similar to triangle PRPQ. Now in starting A, remember when we prove similarity, we have to start by, or the procedure we follow, is we start by stating the triangles that we work in. So we say in triangle ABC and triangle RPQ, and then we need 3 reasons. So the first reason is we see that what we are given is that this angle is equal to this angle. We've also given that this angle B is equal to P, and since we have 2 angles that are equal, we know that the third one will also be equal. So let's write that down. So let's start with A is equal to R, so angle A is equal to angle R, and our reason simply is given. Then angle B is equal to angle P, and that's also given. And then we can say that angle C is equal to angle Q, and our reason is third angle of a triangle. Alright, that's our 3 reasons. So then we can say therefore the triangle ABC, so ABC, RPQ in the right order, is similar to triangle RPQ. And our reason is angle, angle, angle. Alright, now for B, we have determined the values of X and Y. So over here we've got X and there we've got Y. So the first thing we're going to do is write down our proportionalities. We have that AB over RP, AB over RP is equal to BC over PQ, BC over PQ is equal to AC over RQ, AC over RQ. Then we fill in the known values. AB is 4, RP is Y, then BC is 3, PQ is 9, and AC is X, RQ is 15. Okay, so now we can let's start by solving X. Then we have that X over 15 is equal to 3 over 9. Now I can use cross multiplication. I can just take this 15 up and this 9 up. So I can say that 9x is equal to 45, and then divide both sides by 9, and I get that x is equal to 5. So there's a 5. Alright, now for y, I'm going to do y over here. Then I can say that 4 over y is equal to 3 over 9. So I can do cross multiplication. I go and I say that 4 times 9 is 36 equals to 3y, and then divide both sides by 3, so y is then equal to 12. Then for question 2, AE and BD are straight lines, so AE and BD. Prove that triangle ABC is similar to triangle EDC. So we state that we're working in triangle ABC and triangle EDC, right? And we need 3 reasons. First of all, we're working in triangle ABC and then EDC. Alright, now, and also what are we also given? We see that these 2 lines are parallel. Now, first of all, I can see that these 2 angles are vertically opposite, so I can say that angle C1 is equal to angle C2. My reason is vertically opposite angles. Then since these lines are parallel, we see that this angle and this angle, they are alternate angles. So I can say that angle A, is equal to angle E. Reason, alternate angles. And which lines are parallel? AB is parallel to DE. And then finally, I can say that B is equal to D. And I can state that it's the third angle of a triangle. Right, so therefore, triangle ABC is similar to triangle EDC. My reason is angle, angle, angle. And then B, so determine the values of X and Y. So here we have X and there's the Y. And once again, I'm just going to write down my proportion. So AB over ED, AB over ED is equal to BC over DC, BC over DC, and that's equal to AC over EC. Right, let's substitute in our known values. AB we've got as 7, ED we have as X, equal to BC is Y, DC is 10, equal to AC is 5, and EC is 6. Alright, so let's start with X. So we have that 7 over X is equal to 5 over 6. Let's do cross multiplication. We have that 42 is equal to 5x, so therefore X is equal to 42 over 5. Alright, that was X. And then for Y, we have that Y over 10 is equal to 5 over 6. So we apply cross multiplication and we have that 6Y is equal to 50. And therefore Y is equal to 50 over 6. Question 3. Calculate the length of TS. So where's TS? T is over here. And what do we know about this triangle? First of all, we know that it's a right angle triangle. And we have the other two shorter sides. So that means we can use the theorem of Pythagoras, where we have that TS squared is equal to TR squared plus RS squared. Okay, so that is going to be that TS squared is equal to, what is our values? TR is 6 squared plus RS is 8 squared. So that means that TS is equal to the square root of 6 squared plus 8 squared. And that is equal to, so if I just calculate that, we have square root of 6 squared plus 8 squared. This gives me 10. Alright, so that means that is 10. Now for B, prove that triangle PQS is this big triangle, is similar to TRS. So TRS is the small triangle. Alright, so first of all, I'm going to say that I'm working in triangle PQS and triangle TRS. Okay. First of all, 3 reasons, and the first reason is quite simple because we know this S is equal to itself, so angle S is equal to angle S. Now just also a note, if you don't know where to start with this, you need to prove that angle P is equal to angle T, angle Q is equal to angle R, and angle S is equal to angle S. So always look at the order that it is in. If they give you this, then it's already in the right order because this is what you need to prove. So going back to the question, this S is equal to S, so that's given. All right. Then, not given, sorry, that's common. The common angle. Right, now we need to show that P is equal to T. These lines aren't given that it's parallel. If they were, it would have been these would have been corresponding angle. So let's see, can we prove that Q is equal to R? Well, it's already given that they're both 90, so therefore angle Q is equal to angle R1, so that's a given. And then we can say that angle P is equal to angle T1, and the reason is it's the third angle of a triangle. Alright, and therefore triangle PQS is similar to triangle TRS. Okay, now for C. It says determine these lengths QS. So QS is this long side over here. Alright, and what else do we have? We have the smaller triangle's side. And then we have this. So we can say that this PQ over TR will be equal to QS over RS. Okay, so let's put that down. So we have that we want QS. I'm going to write QS first because I want that one. So QS, this side over this RS is equal to my bigger triangle PQ over TR. So now we've done that graphically. Let's just check it algebraically. QS over RS, PQ over TR. Okay, so my proportionalities are correct here. I substitute in my known values, QS over RS, that which is 8, equals to PQ, which is 12 over TR, which is 6. Okay, so let's apply cross multiplication. In this case, I'm just going to take the 8 up. So QS is equal to, and then I'm just going to type that into the calculator. So I'm going to say it's the 12 times by 8 over 6. So this gives me 16 units. Okay, so then that was I1. Second one, QR. So QR, okay, that's quite simple because we have then that QR is this long QS. Okay, so QR will be equal to the long side QS minus this 8RS. So this is going to be equal to 16 minus 8. So that's equal to 8. Okay, and then finally PS. So third one. PS is this long side over here. So once again, we can just use our proportionalities, and I'm going to go with this long side, PS, over TS, the hypotenuse side. So let's write that down. PS over TS is equal to, let's use this side again, PQ over this TR. And once again, I can just check that my proportionality is correct by saying we've got PS should be over TS and PQ over TR. All right, substitute in our known values. PS is the one we wanted, so PS over, what is TS? 10 equal to PQ is 12 over TR is 6. Okay, cross multiplication, we multiply that up, that gives us 120. So PS is equal to 120 divided by 6, that is 20, it should be 20. Question 4. So it's given that angle S1 is equal to R. So this is angle S1, that's angle R, so this is also equal. Alright, so prove that triangle PQR is similar to, let's just establish PQR is similar to angle PTS. So what do we need to prove? We need to show that angle P is equal to angle P. We need to show that Q is equal to T and R is equal to S. So we were working in triangles PQR and triangle PTS, and we need our three reasons, which would be the three angles being equal, if we can prove that. So first of all, since P needs to be proven that it's equal to P, this is the same angle, so therefore angle P is equal to angle P. My reason is it's common, right? Then we are given that S1 is equal to R. So R and S are the ones that we need to prove equal, and we are given that they are equal. So we can say that angle R is equal to angle S1, and we can say that's given. And then finally, the last set of angles is Q equal to T, and we can state that because it's the third angles of a triangle. So Q equals to angle T, third angle of a triangle. Okay, so therefore triangle PQR is similar to triangle PTS, and once again our reason is just angle, angle, angle. Now for B, calculate the values of x and y. So once again, write down our proportions: PQ over PT. PQ over PT is equal to QR over TS. QR over TS is equal to PR over PS. Okay, then we substitute in the known value. So PQ is over here, so this is this 3 plus this 5, that gives us 8, over PT. PT is 4, equal to QR. QR is this 10, TS is Y, PR is this x plus 4, and PS is 3. Okay, right, let's start with the x value. So we have that x plus 4 over 3 is equal to 8 over 4. Start with cross multiplication. So 4 times by x plus 4 is equal to 3 times 8 is 24. Multiply out the brackets. That's 4x plus 16 equals to 24. Take all your constants to the other side. 4x is equal to 24 minus 16. So that would give you 8. Yeah, I think that gives you 8. 4 x is equal to 8. So therefore x is equal to 2. I just want to double check that. So this is going to be 6 over 3. That's 8 over 4. See, that's this one's value is 2. And then if this one is 6 over 3, this one's value would also be equal to 2. Alright, so that was just to double check. Then we can find y by saying 8 over 4 equals to 10 over y. Do cross multiplication. So this is 8y equals to 40. Divide by both sides. Y is equal to 5.
That's all, folks.